Welcome, doctors. I am absolutely thrilled to guide you through today's masterclass explainer on male reproductive endocrinology. As first-year medical students, you're making this massive leap right now. You're transitioning from just memorizing static basic facts to actually understanding dynamic living systems. And today, we're going to explore a continuous, lifelong manufacturing process. Let's just dive right into this fascinating factory of the human body and really see how these microscopic basic sciences translate directly into clinical practice on the wards.
Here's a quick look at the syllabus for our explainer today. We've got 5 parts. First, the spermatogenesis factory. Second, the hormonal command center. Third, disrupting the system. Fourth, psych correlates and vignettes. And we'll wrap up with a high-yield exam review.
All right, Section 1, the spermatogenesis factory, building the gametes.
Let's walk through this chronological, step-by-step pipeline. It's literally an assembly line. We start with spermatogenesis. Here, your primitive diploid spermatogonia undergo mitosis. This is to maintain a stem cell reservoir, while some actually commit to differentiating into primary spermatocytes. Next up is meiosis, which is a 2-part division that slashes the chromosome count from 46 down to 23, leaving us with haploid spermatids. Then step 3 is spermiogenesis. Now careful here, this isn't a division, it's a profound metamorphosis. Those round, kind of clunky spermatids shed their cytoplasm, they develop a flagellum, and they become highly streamlined spermatozoa. And finally, spermiation. That's the active release of these mature cells right into the lumen of the seminiferous tubule.
But listen, to pull this off safely, the body needs a highly specialized environment. Enter the blood-testis barrier. I want you to think of this barrier as a highly secure VIP clean room. Your immune system has never actually seen haploid cells with 23 chromosomes before puberty. If it did, it would ruthlessly attack them as foreign invaders. So you have these bouncer-like Sertoli nurse cells forming extremely tight junctions to actively protect the developing sperm from autoimmune destruction. And on top of that security detail, these brilliant Sertoli cells provide metabolic support. They convert glucose to lactate for the sperm to feed on. And they essentially eat, or phagocytose, the discarded cytoplasm left over from spermiogenesis.
Moving right along to Section 2, the hormonal command center, the HPT axis.
So here we have a really great head-to-head comparison of your 2 key cellular players. First, the Leydig cells. They sit out in the interstitial space outside the tubules. Stimulated by luteinizing hormone, or LH, they are your power generators. They produce testosterone. On the right, your Sertoli cells sit inside the seminiferous epithelium. Stimulated by follicle-stimulating hormone, FSH, they are your factory managers. Now, what you absolutely must remember for the wards is that Sertoli cells secrete androgen-binding protein, or ABP. ABP grabs the testosterone made by the Leydig cells and concentrates it locally in the tubules to levels roughly 100 times higher than what you'd find in the peripheral blood. That massive local concentration, it is completely mandatory for sperm maturation.
Let's see how this all builds into the complete hypothalamus-Pituitary-Testis, or HPT axis cascade. It all starts up in the brain. The hypothalamus releases gonadotropin-releasing hormone, GnRH, in strict pulsatile bursts. If it's not pulsatile, the whole system just downregulates. This GnRH hits the anterior pituitary, which then secretes LH and FSH into the bloodstream. Those signals travel all the way down to the testes, instructing the Leydig and Sertoli cells to produce testosterone and inhibin B, respectively.
The really crucial point here is that this system is entirely self-regulating through 2 distinct negative feedback loops. It's exactly like a thermostat in your house. When testosterone levels rise, that testosterone travels back up to the brain and says, okay, we have enough, inhibiting the secretion of both GnRH at the hypothalamus and LH at the pituitary. Meanwhile, inhibin B, which is produced by our busy Sertoli cells, acts selectively to inhibit only FSH secretion from the anterior pituitary. These elegant feedback loops guarantee that hormone levels never just spiral out of control.
Okay, Section 3, disrupting the system. We're looking at environment and exogenous factors.
Before we even get into drugs or toxins, I want you to consider a fundamental anatomical mystery. Why on earth would human evolution place such a vital organ, literally the organ responsible for the continuation of our species, outside the protective muscular and skeletal shielding of the abdominal cavity?
Well, the answer is pure thermodynamics. Human spermatogenesis is incredibly temperature sensitive. It strictly requires a thermal environment of 32 to 35 degrees Celsius, which is roughly 2 to 3 degrees below your core body temperature. If the temperature gets too high, the factory literally melts down and stops producing. The abdominal cavity is essentially a biological sauna, way too hot for sperm production. And this is exactly why a condition called cryptorchidism, or undescended testes, inevitably leads to sterility if it isn't surgically corrected early in life.
Now let's look at chemical disruptions. Specifically, a classic board scenario you're definitely going to see in clinic. A bodybuilder who uses exogenous anabolic steroids to pack on muscle mass. Remember that natural balance requires local testosterone concentrated by ABP to drive spermatogenesis. But when a patient injects exogenous steroids, it causes a massive spike in their circulating androgens in the blood. The brain's negative feedback loop detects this massive spike, assumes the body has just produced way too much, and completely shuts down GnRH and LH. And without LH, the local Leydig cells just go dormant. Local testicular testosterone absolutely plummets, and the patient unwittingly causes their own severe infertility. So when you're evaluating a patient with oligospermia, a low sperm count, in your clinic, you really have to be a detective. You must systematically rule out these environmental toxins and chemical exposures. Ask yourself, are they working in an industry with heavy metal exposure, like lead or arsenic? Are they heavy marijuana users? Are they taking over-the-counter or prescription pharmaceuticals with known reproductive side effects? Or are they quietly using exogenous anabolic steroids? You have to ask the right questions.
Moving on to Section 4, Psych Correlates and Vignettes, focusing on the mind-body link.
It is just fascinating to see how severe anxiety, depression, and mental stress physically manifest in the body. Intense stress activates the hypothalamus-Pituitary-Adrenal, or HPA axis, surging the body with corticotropin-releasing hormone and cortisol. These high-stress hormones actively cross over and inhibit the reproductive axis. They dampen GnRH release at the hypothalamus, effectively slamming the brakes on the entire reproductive system. This leads to a highly measurable reduction in both spermatogenesis and libido. The mind and the body are one connected circuit, always.
Let's anchor these concepts with a clinical vignette that you will absolutely see in practice, especially on your psychiatry and endocrinology rotations. Imagine a male patient being treated with haloperidol, which is a classic antipsychotic for a psychiatric condition. He presents to you with new-onset secondary hypogonadism, erectile dysfunction, and impaired spermatogenesis. So why exactly did a psychiatric drug cause a reproductive failure?
Using our physiological roadmap, we can easily trace the exact mechanism. First, the neuroleptic drug haloperidol works by blocking dopamine receptors in the brain to treat psychosis. But here's the trick. Dopamine literally is the body's natural prolactin inhibiting factor. So for step 2, with dopamine blocked, the anterior pituitary is suddenly completely free to produce unchecked amounts of prolactin, leading to hyperprolactinemia. And for step 3, this massive excess of circulating prolactin powerfully inhibits the pulsatile secretion of GnRH. The HPT axis completely shuts down, and secondary hypogonadism ensues.
Now conversely, just as psychiatric drugs affect hormones, a lack of hormones deeply affects psychiatric behavior. A patient suffering from primary testosterone deficiency or hypogonadism might not just present to you with sexual dysfunction. They frequently present with severe mood changes. We're talking increased irritability, extreme passivity, profound apathy, or even clinical depression. We also see altered cognitive profiles in genetic conditions that cause low testosterone, such as Klinefelter syndrome, where patients often display a more traditionally feminine cognitive profile simply due to androgen deficiency during brain development.
All right, Section 5, High-Yield Exam Review. Let's look at some testable concepts.
Let's consolidate everything. Commit these essential takeaways to memory. Remember the timeline. Spermatogenesis takes a full 72 to 74 days. Remember your cells. Sertoli cells are the FSH-driven nurses forming the blood-testes barrier, and Leydig cells are the LH-driven testosterone producers. Remember your thermodynamics. Spermatogenesis demands a cool 32 to 35 degrees Celsius. Remember your feedback loops. Exogenous steroids and high-stress cortisol will absolutely shut down GnRH and LH. And finally, never forget your psychoendocrine crossover. Dopamine antagonists like haloperidol cause hyperprolactinemia, which actively induces hypogonadism. Make sure you understand not just what these facts are, but the underlying physiological why behind each and every hormonal interaction.
I want to leave you with this final, provocative thought. In medicine, no system exists in isolation. You've just seen exactly how a stressful life event can shut down gamete production, or how a schizophrenia medication can literally cause infertility. So as you walk onto the wards,
How will you use this profound connection between psychiatric health and reproductive physiology to look beyond the obvious symptoms and become a sharper, more perceptive, and truly holistic diagnostician? Thank you so much for joining me on today's Explainer, doctors. I'll see you in the next one.